Welcome to Bite-Sized L&D, your quick, no-nonsense update on the latest in workplace learning. Today, we're questioning the relevance of advanced math and physics education in college and exploring how these subjects might evolve to better serve diverse career paths. All right, let's get straight into it.
Hey everyone, welcome to another episode of Bite-Sized L&D. I'm Donna, and as always, I'm joined by my brilliant co-host, who barely passed calculus in college, but somehow ended up teaching it to executives. How are you doing today, Yakov?
I'm great, Donna. And for the record, I got a B+ in calculus. Thank you very much. Though I will admit I haven't calculated an integral by hand since the final exam.
Which actually leads perfectly into today's topic. We've got a really interesting discussion lined up about something many of us have wondered silently during those late-night study sessions in college.
Exactly. Today we're diving into the age-old question: why are we required to learn advanced mathematics and physics in college programs when most professionals, even in technical fields like computer science, rarely use these skills in their day-to-day work?
It's such a relevant question. I mean, raise your hand if you've ever found yourself solving a differential equation at work. Anyone? I see a bunch of programmers out there just using libraries and frameworks that do all the heavy lifting.
Right? Most software developers I know are reaching for NumPy or TensorFlow rather than deriving formulas by hand. One computer science professor even admitted that in decades as a computer scientist, they never used anything they learned in calculus or differential equations.
Wow, that's pretty telling. So why do we put students through this mathematical gauntlet? Is it just academic hazing, or is there something deeper going on?
That's the million-dollar question. And there are actually several perspectives worth exploring here. The traditional argument is that advanced math builds critical thinking and problem-solving skills that transfer to other domains.
The old "it teaches you how to think" argument. I've heard that one before.
Exactly. According to educational research, advanced mathematics challenges students to engage in critical, abstract, and logical thinking. The idea is that these courses help students develop what educators call mathematical maturity, a level of rigor and abstraction that supposedly empowers lifelong analytical thinking.
I can see that. When I took calculus, it wasn't really about the formulas themselves, but learning how to break down complex problems into solvable pieces. That skill definitely transfers.
Absolutely, and physics courses are often credited with revealing the mathematical beauty of the universe, while strengthening quantitative reasoning and analytical skills. The argument is that these subjects teach you to construct logical arguments and model change with formulas.
But here's what I keep wondering. Couldn't we teach those same skills with more practical, applicable content? Like, do we need to torture students with abstract concepts they'll never use?
That's where the critics come in. Some educators calculate that U.S. college students collectively spend about 18,000 years of study on calculus each year, even though fewer than 5% will ever use it professionally. That's a pretty staggering opportunity cost.
18,000 years? That's since before the last ice age. When you put it that way, it sounds absolutely bonkers.
It does raise questions about return on investment, and some argue this focus on traditional advanced math has deterred students, especially from underrepresented groups, from pursuing STEM majors. It becomes a gatekeeper rather than a gateway.
I've definitely seen that in action. So what are the alternatives people are proposing?
Many educators suggest that courses in statistics, data analysis, or discrete math would be more relevant for most careers. The focus would shift to quantitative reasoning and real-world modeling rather than proof-based calculus.
That makes a lot of sense to me. I mean, everyone needs to understand data these days, but not everyone needs to know how to integrate by parts.
There's actually a reform movement happening in places like California, where they're debating whether courses like data science could replace advanced algebra as college preparatory math.
Interesting. But I imagine there's pushback from the math traditionalists.
Of course, proponents of calculus argue it builds deeper understanding, and others worry that moving away from it will weaken fundamentals. It's a classic depth versus breadth debate in education.
Let's shift gears a bit. What about the global perspective? Do other countries approach this differently?
Great question. In China, for example, engineering universities mandate calculus, linear algebra, and statistics as core courses. The stated goal is similar to Western education, cultivating abstract thinking and logical reasoning as well as problem-solving skills.
So the justification is pretty much the same then?
Yes, but with some cultural differences. In China, math is seen not only as a set of tools, but as a way of thinking, and even as a sign of a nation's scientific culture. However, they face different challenges. Their intense exam system can lead to rote learning that kills students' interests in math.
That's fascinating. So while we're questioning whether our approach is too rigid, they're questioning whether theirs is rigid in the right way.
Exactly. And here's another interesting angle. Physics departments love to point out that physics majors have among the highest scores on medical and law school entrance exams, even though there's no direct connection between physics and medicine or law.
That suggests there really is something to the teaches you how to think argument. Maybe what we're learning isn't the content itself, but a way of approaching problems.
I think that's a key insight. When Stanford's physics department says studying physics and math produces a strong quantitative background that can be applied in any technical field, they're talking about transferable mental models, not specific formulas.
So perhaps the debate shouldn't be whether to teach advanced math and physics, but how to teach them and how to make their broader applications clear to students.
I think that's right. The evidence suggests these subjects do build valuable cognitive skills, but we might need to reconsider our pedagogy and emphasize the thinking patterns rather than rote memorization of formulas.
What about those Python libraries and Excel spreadsheets, though? If tools can do the heavy lifting, shouldn't education focus on using those tools effectively?
That's the pragmatic view. Modern tools like NumPy, SciPy, or TensorFlow perform sophisticated math under the hood, so developers rarely need to derive formulas by hand. In specialized tech fields, like databases or web apps, calculus is often of little use.
It reminds me of the debate about whether kids should learn long division when calculators exist. There's value in understanding the process, even if you ultimately use tools.
Great analogy. And it's worth noting that in specialized niches like computer graphics, digital signal processing, or machine learning, that underlying math knowledge becomes crucial again. You need to understand what those libraries are doing under the hood.
So maybe the answer isn't one size fits all? Perhaps different career paths should have different mathematical requirements?
That's becoming more common. Some universities are developing CS-tailored math courses that focus on discrete math, algorithms, and statistics, rather than traditional calculus sequences.
It sounds like we're seeing an evolution in how we think about mathematical education, moving from everyone needs calculus to everyone needs quantitative reasoning, which might look different across fields.
Exactly. As one California task force put it, college math should support the ability to reason with and make inferences from quantitative information in order to solve problems arising in personal, civic, and professional contexts.
I like that framing. It's about the mindset, not just the formulas. So where does that leave us on our original question? Is advanced math and physics education worth it?
I think the evidence suggests yes, but with caveats. These subjects build valuable cognitive skills and provide foundations for specialized work. But we need to be thoughtful about opportunity costs and consider whether alternative approaches might be more effective for certain students and careers.
That feels right to me. And maybe we need to do a better job of communicating the why to students. Not just learn this formula for the test, but here's how this type of thinking will serve you later.
Absolutely, understanding the purpose makes the difficult journey more meaningful. And for what it's worth, even though I haven't calculated an integral since college, the problem-solving approach I learned in those classes shows up in my work every day.
Well, folks, there you have it. Advanced math and physics might not be about the specific formulas you'll use, but about training your brain to approach complex problems systematically. Whether that's worth 18,000 collective years of study per year, well, that's for each of you to decide.
And we'd love to hear your thoughts. Did you find those advanced math classes valuable in your career? Or do you think we should be teaching different quantitative skills? Let us know in the comments or shoot us an email.
That's all for this episode of Bite-Sized L&D. I'm Donna, and this math enthusiast next to me is Yakov Lasker. Thanks for tuning in, and we'll catch you next time.
Make sure to like, subscribe, and calculate the limit as our subscriber count approaches infinity. We've explored the role of advanced math and physics in education, discussing how they foster critical thinking despite their limited use in many careers and the barriers they create, especially for underrepresented groups. Consider alternative approaches to math education that emphasize thinking skills over memorization. Don't forget to like, subscribe, and share this episode with your friends and colleagues so they can also stay updated on the latest news and gain powerful insights. Stay tuned for more updates.